In this problem, we have to find an integrating factor of the form x to the n, y to the m to solve the equation. So this equation appears to be an exact equation, but is not. So if you compute the derivative of m respect to y and the derivative of n respect to x, you will see that the equation is not exact. So we're going to multiply the whole equation by a factor of the form x to the n, y to the m. So we have our equation 2y squared minus 6xy dx plus 3xy minus 4x to the second dy equals 0. And then we're going to multiply by x to the n, x to the m. So if we do that, we are going to multiply x to the n, x to the n, y to the m. Sorry, this should be y to the m, by every term in the equation. So if we do that, we have an equation which is 2x to the n, y to the n plus 2 minus 6x to the n plus 1, y to the n plus 1 dx plus 3x to the n plus 1, y to the n plus 1 minus 4x to the n plus 2, y to the m dy equal to 0. Remember, when you multiply a basis, equal basis, you add exponents, right? So when you multiply the same letter, then you're going to you're going to add the exponents. So the condition for the equation to be exact, we know it is derivative of m respect to y is equal to derivative of n respect to x. So what is the partial derivative of m respect to y? Okay, so let's say that our portion shaded in blue is our m, right? And our portion shaded in yellow is our n. Okay, so what? Derivative of m respect to y? It is 2 m plus 2 x is the n, y to the n plus 1 minus 6 m plus 1 x to the n plus 1 y to the m. In the same manner, derivative of n respect to x would be 3 m plus 1 x to the n, y to the n plus 1 minus 4 m plus 2 x to the n plus 1 y to the m. So we want our derivative, our partial derivatives to be the same. So as you can see, the terms I'm shading in green have the same exponents, right? Same letter, same exponent. The term I'm shading now in violet, they have the same letter with the same exponent. So the coefficients they should be the same, right? Coefficients, they should be the same. So we get to the conclusion that 2 times n plus 2 should be equal to 3 n plus 1. And then negative 6 n plus 1 equal to negative 4 n plus 2. So we solve this system of linear equations. This equation is equivalent once we distribute and combine like terms. We have 2m minus 3n equals to negative 1. And the second equation will be 6m minus 4n equals to 2, right? Then we can, this is a system of linear equations. We can multiply the first one by negative 3, for example. So we multiply this one by negative 3. Our new system becomes negative 6m plus 9n equals to 3. 6m minus 4n equals to 2. Then we have that 5n equals 5. Therefore, n is 1, right? In the same manner, if you replace n equals to 1 in any of the equations, you're going to conclude that m is also 1. So our integrating factor, right? Our integrating factor depending on both x and y is x to the n, y to the m. So in this case, it's x to the 1, y to the 1, right? So just x, y. So once we plug 1 as n and 1 as m in, let's say, equation number 2, this equation number 2, that is the result of multiplying everything by x to the n, y to the m. So our equation becomes what? Our equation is going to be 2x y to the third minus 6 x to the second y to the second dx plus 3x2 y2 minus 4x 3y dy. And then if you check, this equation is exact because the derivative now of m respect to y is going to be the same, or is actually the same as the derivative of n respect to x. So it's time to compute the function f of x comma y, which is the integral of m x comma y dx plus g of y, and that is the integral of 2x y3 minus 6x to the second y squared dx plus g of y. And this integral results as, remember the integral is only on x, so we have x to the second y3 minus 2x to the third y squared plus gy. Then the next step is to find g of y. So for this reason, we find derivative of f respect to y, which is going to be our n of x comma y, right? Remember, this is our new m, okay? This is our new m, and this is our new n. So derivative of the function respect to y is 3x y squared, 3x y squared minus 4x 3y plus g prime of y, and that is going to be equal to n. And what is n? N is the expression shaded in yellow, which is 3x to the second y squared minus 4x 3y, and then this term and this one cancel, this one and this one cancel, right? So g prime of y is 0, so g of y is a constant. I'm going to call C1. So our solution is f of x, which is x to the second y3 minus 2x3 y squared plus C1 equals C. So when I move C1 to the other side, I can call again this constant as C. And this concludes the problem.